Hi everyone, welcome to our fifth session with the Farmland Drainage and the Environment Conference. Today we are hearing from Bob Halliday, and he is presenting on Farmland Drainage Hydrology, more than the draining of wetlands. So before I introduce Bob, I'd like to just take a moment to acknowledge the numerous treaties across Saskatchewan. We have treaty number 2, 4, 5, 6, 8, and 10. Saskatchewan is also the traditional home of the Plains Cree, the Saulteaux, Nakota Assiniboine, Dakota, Lakota Sioux, and the Dene Siouxland people. Saskatchewan is also the traditional home of the Métis Nation. So I'd like to just thank and acknowledge the Indigenous people whose footsteps have marked this land for centuries. This conference is brought to you by the Citizens Environmental Alliance and many, many like-minded organizations. The goal of the conference is to increase awareness of the different imperatives around farmland drainage. So just a few housekeeping notes. Your mics are all on mute for the duration of the presentation, and we will be taking questions at the end of the presentation. So if you'd like to go ahead throughout Bob's presentation, you can type in your questions in the question box on the GoToWebinar dashboard. So without further ado, I'll introduce our speaker for today. So Bob Halliday is the president of R. Halliday and Associates and has practiced as a consulting engineer in Saskatoon for about 20 years. He previously worked for Environment Canada and is a former director of Canada's National Hydrology Research Centre. His interests include interjurisdictional water management, floodplain management, and the effects of climate change on water resources. Bob has appeared in court as an expert witness on flooding and drainage issues. He's the author of the flooding chapter in a recent Saskatchewan flood and natural hazard risk assessment. So without further ado, Bob, we're happy to have you, and we'll pass it over to you.
Thank you, Lindsay, and I appreciate the introduction and the welcome. I will be talking for, I think, 30 to 40 minutes, and that should allow enough time for questions at the end of the presentation. And I have a few slides to step through. I think maybe I'll turn that off. And what I want to do today is I'm trying to get my slides to advance. I'm sorry.
You might have to click on the PowerPoint presentation, or there is a little arrow at the bottom left. Oh, there it goes.
Yeah, that's better. I've got too much stuff on my dashboard still. There we go. Yeah, so what I'm going to do today is I'll chat a little bit about characteristics of watersheds in Saskatchewan and the southern part of the province where drainage is an issue. And I'll speak to some of the recent flooding and my own sort of analysis of drainage and hydrology issues. And I'll close with a few conclusions. And by all means, put questions in the chat box as we go. Generally speaking, our Saskatchewan Prairie, to no one's surprise, is flat, but it's a low relief, flat topography, and covered by depressions that are the result of glaciation thousands of years ago. I like to think of a drainage as what I call disorganized. There are relatively few incised streams, and a lot of the landscape just consists of potholes and some minor interconnections. And this climate that we're exposed to is known technically as humid continental, which just means that there's no pronounced dry period during the year. And in the Southwest, of course, it is a semi-arid climate. And another important aspect of our topography and our drainage patterns is that throughout the southern Saskatchewan, evaporation exceeds precipitation. So in the absence of any inflow, a body of water will decline in water level as the year goes on, unless there is inflow from the landscape. And then, of course, we have a typical runoff pattern of spring snowmelt in April. It leads to runoff, and that precipitation during that April runoff can increase the runoff. But by and large, the rain that we get during the summer enhances crop production, but it rarely results in runoff. So the wet years of past few years where we've had June and July floods is rather unusual in a Saskatchewan context. The other little piece of information is that there's little base flow, which means that the surface water drainage system is rather poorly connected to the groundwater system. And so in many parts of Canada, the groundwater system sustains stream flow late in the season, but in many cases in Saskatchewan, we have ephemeral streams that dry up almost immediately after the spring runoff and don't run at all until the fall. Just a map of evaporation on the prairies, and the only point here is that evaporation in southwest Saskatchewan is about 1 meter a year. So this is not a trivial amount of evaporation. And in the southwest, of course, precipitation is less than 30 centimeters. So there's a very, very large gap between evaporation and precipitation. And another key element of prairie water systems is this question of what we call non-contributing drainage. And I think this wording has become endemic in our hydrological discussions, but it was actually the whole concept of non-contributing drainage was invented by two people named Bill Stickling and Stan Blackwell in the 1950s. And it's really a very significant concept. It's easy to describe and hard to administer, because what they're saying is that our prairie streams tend not to contribute to the flow of main rivers. And this area that's marked in red on this map are those areas which naturally would not contribute to stream flow 1 year and 2. So in other words, that whole red area is unlikely to contribute to stream flow half the time. And of course, the key word in this definition is naturally, because if we start connecting up some of those non-contributed areas by drainage channels or whatever, then they may contribute to stream flow. And that, so the word natural is important, and it's important to realize that that's part of a definition of so-called non-contributing drainage. And of course, that area includes most of the agricultural land in the province, and it includes what we tend to think of as the prairie pothole terrain. And when we look at our Saskatchewan watersheds, there's a tendency, especially for geographers and engineers, to want to classify things. And how do we define these watersheds? And you know, what can we say about them? And you know, of course, that non-contributing area that I showed in the previous slide can be divided up into a series of sub-watersheds. And these sub-watersheds tend to center on a prairie pothole and the surrounding elevations. And when the pothole fills up, it naturally will overflow to another pothole. And when we start changing the landscape by drainage, we are actually improving the connectivity of these little potholes, and that leads to changes in hydrologic behavior. And so we need to understand what happens when we do connect up potholes, and how does the behavior change, and what happens if some characteristic changes other than the pothole, and that characteristic could be simply climate. And so getting that understanding of how watersheds function and what people like me call process hydrology is fundamental to understanding drainage on the prairies. And we can examine things like climate or topography, the actual landform and superficial geology, distribution of wetlands, and the actual cover of the land. All of these things can be considered in trying to classify a watershed. And Jared Wolf and his colleagues at the University of Saskatchewan have done an amazing classification of the entire prairie ecozone, and it's shown in this map. And what I find, just at a glance, what I find interesting is that this map doesn't show provincial boundaries, and yet you can see they're distinctly different classifications of land in southern Alberta as opposed to Saskatchewan, as opposed to Manitoba. So it's interesting in its own right. And but this classification is based on a careful examination of many, many attributes of our prairie landscape. And if you look closely, probably in the light blue or the green areas, you can see each of those sub-watersheds that Jared and his colleagues considered in coming up with this classification. And what's evident is that that blue area, light blue area on this in southern Saskatchewan, which they call the pothole till area, and also the pothole glaciolacustrine area, and that Regina Plain and Moose Jaw Plain. This is the prairie pothole country that largely shows up in red in the previous slide. And so understanding that that land classification and the runoff that might occur on that landscape is important to understanding prairie hydrology. If we then turn to some of these classified areas, and turning to the rather busy diagram on the right, you can see that this is the effect of land drainage on the high plains in Alberta, which is shown in green in the small map. And each of those dots constitutes annual runoff for a year. And these are what are known as box and whisker plots, but most of a runoff or half the runoff occurs within the box. And you can see on the right-hand figure that if you drain that high Alberta plains, the runoff tends to increase as a percent of drainage increases, but it doesn't increase a lot. And it's generally a slow rise in runoff in southern Alberta as you drain the landscape. If you turn to the left-hand figure, which shows that pothole till area in blue on that map, in the little map, you'll see that as you drain that pothole till landscape, it tends to be fairly unchanging in runoff until you hit to about 40 to 50% of the landscape being drained. And then as you increase drainage, the annual runoff increases quite significantly. And that's quite the change is quite dramatically different than looking at the drainage characteristics of the high Alberta plain. And this is yet unpublished data from the Global Water Futures Project, Prairie Water Project. But we'll see more results of this kind of analysis within the next year or so. And I'm expecting to find that the so-called pothole till areas that were shown in red on that non-contributing drainage map will show a similar drainage response to the figure on the left, and it'll be less likely to be the figure on the right. So this is something to keep an eye on as we increase our understanding of prairie runoff and the effects of human activity on that runoff. And just to kind of add to the that prairie runoff situation, this map is the Water Security Agency's map of drainage vulnerability, and the area in red and kind of dark brown black in here jives relatively closely to the pothole till and area that was shown in Jared's work. And this area in red is where the Water Security Agency deems the effects of drainage to be significant. And in fact, with the current strategy, they would say that if 50% of landscape is drained, that's enough, and no more drainage would be allowed. So there's some convergence between the Water Security Agency's take on drainage vulnerability and the work that's being done at the University of Saskatchewan. If we turn now to the flooding question, as we all know, back in the 2005, 2006, there were very significant floods in part of southern Saskatchewan, and even more so in 2010 to 2015. So the question is this flooding the result of drainage, or is it the result of climate? And as you might imagine, it's not a simple question to answer. Just to emphasize the significance of the flooding in recent years, these are flood disaster assistance payments by the province over the last several years. And you can see the enormous payout in 2011, over $160 million related to flooding, and many more millions in other years. We turn now to the flooding question and take a look at the trends in water levels in so-called closed basins. These are lakes in Saskatchewan and one in North Dakota that have no usual outlet. And so the water flows into the lake from a drainage basin, and the water level moves up and down in response to that incoming water and the evaporation and the precipitation on the lake. And this is work done by Garth Vanderkamp and his colleagues, but it's been updated to the present day for some lakes. And you can see in looking down this chart, it shows the water levels in several lakes by year, and starting with Manitou Lake up near the Alberta border, Redberry Lake north of Saskatoon, Big Quill Lakes to the east of Saskatoon, Kenosee Lake in southeast Saskatchewan, and Devil's Lake in central North Dakota. And you can see that there's a general pattern of increasing water levels through all of these lakes. And what's important to note is that there's very little land drainage around Redberry Lake or Kenosee Lake, and actually all said and done, relatively little land drainage around Big Quill Lake. But all of these lakes show somewhat the same pattern. And so the conclusion one might draw is that the high lake levels in recent years is a result of precipitation and climate rather than drainage. But as I mentioned earlier, this is not all straightforward. We can take further look at the hydrology of these lakes and southern Saskatchewan by considering various moisture indices. And many people have heard of the Palmer Drought Severity Index, and most of these moisture indexes were developed to have a look at drought situations, but we also have application to flooding situations. And the Palmer Index has been used for many, many years. Other indexes are a standardized precipitation index. And more recently, we've had what's been known as a standardized precipitation evapotranspiration index, or SPEI. And this is an index that depends both on precipitation and potentially evapotranspiration. And it's interesting to see when you plot that index for southern Saskatchewan what the results look like. And this is a plot of precipitation evapotranspiration indices for 100 years in southern Saskatchewan. The upper plot is Regina area, and the lower one is Prince Alberta area. And this work was done by Virginia Whitrock and her colleagues for a flood assessment and a natural hazards risk assessment in Saskatchewan. What you'll notice in this plot, the blue lines are wet years, the red are dry years, and the black line is a 5-year moving mean. So it tends to show trends in climate and trends in precipitation over that 100-year period. You'll see in the early 1900s, when Saskatchewan was first settled, it was a relatively wet period, and that's the settlers flocked in, and times were good. And then as time went on, we had some drought years and a few high years, and then the 1930s drought is very evident in these plots. And then in the 1950s, we see a series of wet years, and again, times for agriculture were good, and there wasn't a lot of flooding in those years, but there was some flooding. The next highest level is in the mid-70s, when there was significant flooding in Saskatchewan, and this is another wet period. And then finally we come to a few wet years in the 90s, those wet years in 2005, 2006, and then the wet period that's lasted from 2010 on and until just about the current day. So these climate trends are very indicative of runoff, as you might imagine. And of course, some of the runoff leads to different policy changes in government. And this takes me to the drainage challenge. And when we have high flows and wet periods, people like to drain to improve their viability of their land. And it's been estimated there's over 100,000 unlicensed drainage works in Saskatchewan, and somewhere upwards of 1 million hectares of unapproved drainage. But the point I wanted to emphasize here is that our drainage policies can be closely linked to hydrological events. And so in the early 1900s, where we had abundant water, this led to the first Drainage Act in Saskatchewan, which was about 1912. And then in the 1950s, the conservation and development districts became active. These districts were actually set up just around 1950, partly as a drought measure in reacting to the 40s, but in the 1950s, the C&D districts became the mechanism for a considerable amount of land drainage. And the other mechanism for land drainage in the 1950s, which people don't tend to remember, is that was the big era of developing the Saskatchewan grid road system. And the Saskatchewan grid roads that were developed in the 50s tended to have surfaces that were elevated above the prairie level, and that elevated roadway was made possible by taking land from the ditches and building up the road. So then you had a high quality road with ditches alongside of it, and it became very easy for farmers to just run a furrow from their local pothole into the road ditch and drain some land. And so and then of course, high 1950s were high water levels, and drainage was important to farmers. Again, we find the mid 70s, we had flooding, and that led to the 1980 Drainage Control Act in Saskatchewan. And then the 2010 to 2015, flooding led to the 2015 water drainage strategy. So we tend to drain in response to hydrologic conditions, and of course, every time there's a high water period, there's more pressure for politicians to make decisions on drainage and to move ahead on some kind of drainage regulation. So in trying to separate the question of hydrology and drainage, we need to know things. And some of these things, right now, I think it's fair to say that the Saskatchewan drainage strategy depends on information that we don't have. And so these are some of the gaps that I see in trying to inform a drainage strategy and moving ahead and making progress on land drainage issues. And first of all, the Saskatchewan flat landscape does not have a highly developed topographic mapping system. And many of you have heard of LIDAR, which is a very accurate way of mapping the landscape. And Saskatchewan is one of the provinces with the least amount of LIDAR coverage. So it's almost impossible to determine the movement of water on this landscape where one pothole is filling and spilling to another, either naturally or with the assistance of drainage, if you don't even know which way the water's going to run. And LIDAR topography is accurate to about 1/10 of a meter. And when you have maps that show the topography to a meter or two, it's not very helpful. The other thing is that in our precipitation data is pretty sparse in Saskatchewan. Environment Canada has shut down many of its climate stations over the last several decades. And John Pomeroy and his colleagues in working at Smith Creek found that using precipitation data from Yorkton to try to inform models of Smith Creek drainage just wasn't sufficient. And John had to set up his own precipitations right in the watershed to try and get a handle on the effects of drainage on runoff and water quality. And Saskatchewan does have an ag climate network of precipitation gauges, but that information is proprietary and is not generally available to the public or to people that are trying to understand drainage issues. And then thirdly, in the technical sense, it may seem almost irrelevant, but the effects of culverts on land drainage are very, very significant. And again, one of the little engineering aspects of culverts is if a culvert is free flowing, it carries twice as much water as if the outlet is blocked by another water body. And so understanding the effects of culverts and how they might help modify runoff is an important part of understanding drainage. And if you look at many Saskatchewan RMs don't know where their culverts are, and other RMs know where their culverts are, but the culverts are all bashed up from mowers and snowplow blades. And so understanding culverts and their effect on drainage is important. And Harvey Hill and his colleagues, when they did a survey of some overland flooding in the province or some years ago, actually documented the location and dimensions of culverts as part of that exercise. Then the next step on our knowledge gap is what I call our understandings. And you know, I pointed to some of the work that the Prairie Water Project is doing on understanding runoff and water quality based on land classification. I think the outcome of this work will be very significant in trying to understand drainage in the future and the effects of drainage on the downstream. The other challenge with understanding drainage is the cumulative effects of all these small decisions that individual farmers have made over the years. And cumulative effects analysis tends to involve a larger chunk of the drainage area. And again, you're teasing out the effects of changes in one part of a landscape related to changes in other part of a landscape becomes very, very challenging and difficult. And so cumulative effect understanding is important to moving forward on drainage matters. And then, of course, superimposed on all of this is the effects of climate change. And there's the climate change scenario that we're facing now tends to indicate that we have much greater chance of extreme events in the future, either more floods and more droughts, so double jeopardy in that sense. And generally speaking, we can expect, at least in the next few decades, that the amount of water on the prairie landscape will tend to increase, and runoff, and certainly precipitation will increase, and runoff could well increase. So if you're a landowner who's been flooded in the past, I can pretty well guarantee you that you will be flooded in the future. And so we need to change our understanding of how climate change will affect us and act responsibly to dealing with climate change and hardening our landscape against climate change. I think that leads to my conclusions, and that's, you know, is the question of drainage or hydrology the main factor in the flooding we've seen in recent years? And I think the short answer to that question is it depends. And I think our state of knowledge can demonstrate that drainage is a very significant factor in increasing runoff for high frequency events. So the smaller floods that we see and the overland flooding that we've seen in recent years could well be the effect of drainage. But when you start to get the very large hydrologic events, like the runoff that we experienced in 2011, which in that period, some of those runoff events were in the order of events that only happen on average once in 100 years. When you get to that stage of runoff, the landscape is saturated. Most of that non-contributing drainage that I mentioned earlier is contributing. And so the rare events that we see and the flooding from those rare events is most likely to be entirely natural rather than the result of drainage. And then, of course, we have our, the information gaps that I've just discussed, and we need to understand the climate, the topography. We need more stream flow data to have a better look at some of these things. And then we need to have the knowledge gaps filled and understand stream flow processes and the cumulative effects of that drainage. I think I'll stop at that point and let's have some questions and discussion. Thank you for your attention.
Great, thank you so much, Bob. I'm going to hop back on here. So we have lots of questions in the chat box. If you haven't typed out your question, please take the time to do so. And all right, let's get started. So our first question is the water in licensed ditches considered private or public?
In general, water no one owns water in Saskatchewan, but the province has the right to administer water, and I think there was ample evidence that the stream bed is owned by the province. So if there's water in a ditch, and that project is as a licensed project, no one owns that water, and the province has the right to manage that water. But that's the way I would put it. And so I don't think ownership of water is in the cards at all.
Okay, thank you. Our next question, you mentioned that WSA is considering requiring landowners to keep 50% of wetlands. Is this by surface area or by volume? Which should it be?
That's a question to be answered. And in general, there's a few things with that policy that needs work. And one of them is just what was the original wetland area. And I think generally speaking, I think the first approach is to look at the area of wetlands, not the volume of wetlands. But I think in determining what was the original wetland area is a challenge in its own right. And then under the drainage rules that the province is bringing into fore, the farmers can compensate for loss of wetlands due to a drainage project. And there's still a discussion of if you remove a pothole, can you compensate for that loss by sort of safeguarding an upland area? And of course, anyone that's involved in waterfowl management would say you can't compensate for the loss of wetland by increasing the upland. The two are, totally different things, and you need to compensate wetland loss by replacing wetlands. So there's a real challenge in how you define these questions related to even though the policy says only 50%, no more than 50% of a wetland in that red area can be drained. Just understanding the implications of what that means, and then with all the hundreds of thousands of hectares of drained land, and which in theory have to now be licensed. That's a challenge in itself, and it's an enormous task, and quite frankly, it'll take generations to sort out.
Yeah, thank you. I think many people on the call would agree that it is a tricky situation, definitely. Our next question is similar. So you had presented a graph about the difference between increasing runoff between southern Alberta and Saskatchewan, and that there was a bit of a tipping point between the 40 to 50% drainage would drastically increase runoff. Do you know if what baseline was used for that 40 to 50%, whether that was historical wetlands or if that's from the current amount of wetlands on the land?
No, it is a time series. So they did go back to the original, what was deemed to be the original wetland situation, and then advance that through the years, so that it was a percentage loss of the original wetland area.
Okay, thank you. All right, our next question here, being more concerned with flooding rather than drought, are we changing parkland to prairie by removing the majority of surface water and permanent cover? So, and then it continues, changing the SPEI, so you'll have to remind us what that acronym is for, going from humid to semi-arid.
Yeah, I think there's, excuse me, there's several things in play here, because part of that transition from a prairie landscape, or in the transitional area from a prairie parkland landscape to a prairie landscape, part of that is a climate signal. And so we're seeing some changes due to land clearing, and certainly you know, there's loss of wetland, but there's also loss of woodland in that parkland country that's taking place. And so again, that's trying to tease apart the human effects. And even though climate change is a human effect, I make that distinction, that there's a climate effect and the physical act of modifying wetlands or modifying that parkland landscape. And so both of them come into play. And I think, again, we don't have the data to really examine closely which is the dominant factor. But in general, you know, in wet periods, farmers tend to want to drain land. And also back in the 1970s, when we had a wet period, quite a few of the southern Saskatchewan shelter belts were removed because farmers saw them as trapping too much snow and leading to loss of agricultural land for farming during that 1970 period. And then, of course, the 1980s came along, and we ended up in some significant drought years in southern Saskatchewan, and some of the shelter belts went back in, but some didn't. So again, I hate to keep repeating it, but it's complicated, and I appreciate the question, but it's hard to give a definitive answer.
Right, thank you. Our next question, I think, also has a bit of a comment built in. So you made the comment that there's very little drainage in the Quill Lake. Are you aware that the WSA has said that drainage has contributed to the high lake levels and the flood? So according to WSA's report, there is over 88,000 acres of drained wetlands, which amounts to 38% of the inflows into the Quill Lakes. So I think, do you want to make a comment about just the Quill Lakes and the flooding hydrology versus drainage?
Yeah, and it's what I was thinking of, and when I mentioned it was relatively little, is that there's a lot of non-agricultural land around the Quill Lakes as well. And so I was trying to get a sense of the degree of sort of the percentage of agricultural land, and then how much of that was drained. And so I'm not sure if the 38% figure applies to the entire drainage basin, or whether it just applies to the agricultural land that was drained. But it is I'm not denying that there's agricultural drainage around the Quill Lakes. I'm just raising the question of to what extent is that drainage significant in the increase in lake level. And I haven't seen that WSA report, so that would be, I should look at that myself.
Sure, thank you. Yeah. Our next question here is regarding how WSA has been moved from the Department of Environment to the same department as Highways and Transportation. So the Sask government budget 2020 shows highways as the #1 investment for the province. Do you think they are using taxpayers' money to pay for moving water for the agriculture? Does this put businesses that do not have licenses at risk?
Yeah, you know, government organization is always fascinating to watch. Manitoba has just moved their water people into the agriculture department, and you know, just seeing how water is administered and is a challenge. And we all recall the 1980s when the Saskatchewan Water Corporation was set up ostensibly to put everything to do with water under one umbrella. And water is one of those things that intersects all over the provincial scope of activity, and it's very, very difficult to organize government so that you can, in fact, isolate water. And I'm of a view that water, by trying to isolate water in one department, you may create more problems than you solve. But all said and done, water administration depends on people. And if you reorganize and if you have good people going into the new organization, you'll get good work done. If you have poor people going into the organization, you'll have poor work done, irrespective of where those people are housed. And but I do, in talking about highways and water, it's you'll recall I showed a diagram of flood damages in 2010, 2011, and you know, flood damages in the order of over $100 million. For about $100 million, you could obtain LiDAR data for the entire southern part of the province. And this would allow highways to build better roads. It would allow SaskPower to build power lines and know what they're dealing with on the power front. It would allow farmers to deal with drainage issues, and on it goes. So I think there's scope for synergies among departments and making things happen. And we just have to wait developments on the current government organization.
Yeah, definitely. Our next question here is that you mentioned that the F2 events are natural. WSA drainage projects are licensed at F5. Does this mean more water above what is natural, that we should expect to see more water than what is natural, and should we be concerned?
Could you repeat the question? I didn't quite catch it.
Yeah, definitely. So you mentioned that the F2 events are natural and that WSA projects, drainage projects, are licensed at F5. So does this mean that we would should expect to see more water above what is natural, and should we be concerned?
No. Yeah, I think, as I mentioned, there will be more water unquestionably, because the lower, the smaller floods will increase in size, runoff will increase due to land drainage. But I'm thinking that the large events will be largely unchanged, and so it's a question of I think needing the specific information at a specific site and doing an analysis that way, rather than to try to develop broad statements of what's going to happen at a certain location or time or whatever. But in general, land drainage leads to more water, and it also leads to changes in water quality, which we haven't talked about much today. But I think that's the end result will be that there'll be more water in the system, but these will be increases in flows due to relatively small floods rather than the large ones.
Right. Okay. Thank you. Our next question is: will draining the potholes early in the season eliminate the small amount of base flow that we do have for the streams that flow throughout the year in the south?
Yeah, you know, this is the other critical question in trying to understand prairie hydrology, because the timing of water movement in a system can either lead to peak flows combining, or in fact lead to peak flows not occurring at the same time. And so in a year where the two potholes, let's say, are draining into another area and the peaks coincide, that'll augment that peak flow. In another year, those peaks may not coincide, and it'll actually drainage may lead to a decreased flow, a decreased peak flow. And it's a question of, in many cases, of whether you're trying to reduce a peak flow or trying to reduce a flow volume. And of course, if you're draining into another lake, that flow volume is important. But peak flows can either combine or cancel each other out. And so draining a pothole early with the idea that you might reduce flows downstream may work in 1 year, but it may not work in another year. And we've seen that in a number of occasions, and most notably in the Souris River. You'll notice there's a drainage project known as Yellowgrass Ditch that goes back over 100 years, and the Souris River has actually two distinct flood peaks. One is the flood peak in the lower Souris from runoff from the Prairie landscape, and then the other peak is the one from the Yellowgrass drainage project. And generally those peaks don't coincide, but in rare years they could coincide and cause downstream problems. But if you examine the hydrology of a specific catchment closely, you can tease these different effects apart. But again, it takes a lot of data and a lot of intellectual effort to do that, and the answer isn't always clear when you start.
Yeah, that's fair. Our next question has to do with the drainage pilot project that WSA is doing. So there are many drainage pilot projects throughout the province evaluating many of the science topics discussed throughout this presentation, including the location of culverts and culvert sizing. So the person was just wondering if you had any updates on these pilot projects or any comments that you'd like to add on that.
No, I don't. But in general, the one thing that's all of these projects have in common is that they tend to do take accurate topography. So they do LiDAR surveys, so they understand the topography. They also look at the hydrology of that watershed to get a good sense of what culvert sizes are required. And and this is work that can be done, but because everybody that does it has to start from scratch, there's not this generally available data. It means that anyone that wants to closely look at a specific drainage situation has to collect their own data and do their own modeling, do their own studies, and then you can't easily transfer that finding to another sub-watershed. And so it's a kind of a patchwork. And so I think there's an expectation that the pilot projects will lead to broadly applicable findings. And I'm not so sanguine about that. I think that what the pilot projects will lead to is that if you want to look at drainage in detail, you have to look at that specific area. And so I think the optimism of generally applicable findings might be misplaced, and work needs to be done on developing the data sets that would allow people to do informed calculations without having to spend a pile of money on doing it. I should say too, on these pilot projects, the provincial policy or strategy calls for the use of so-called qualified persons. And I think the expectation was that a qualified person would be some sort of engineer who would make all things good for that sub-watershed. And I suspect that the challenge of drainage in Saskatchewan relates as much to landowners coming to common sense of what's needed, and I think the qualified person may be the right sort of person to do public consultation and social interaction between a group of farmers might be equally as valuable as a person that can just crunch the numbers and say, here's what's going to happen if you build that project. And so it's something to think about as when we think of who we need to help us determine the facts of a drainage issue, it might be a person that can work with several people effectively and draw people together to come to a common view. That's the kind of person you need as a qualified person rather than a number cruncher.
Interesting comments. Thank you. Our next few questions have to do, coming back again to hydrology versus climate. So if wetland drainage increases connectivity, would this not increase the frequency of extreme events, especially once the thresholds you illustrated are breached?
Yeah, and then the challenge here is that as the event becomes a bigger and bigger event, the effective drainage becomes smaller because in a flood like a year like 2010, 2011, the whole basin was contributing water to the system anyway. And so the fact that you've connected up all these potholes by drainage becomes irrelevant. But in a smaller flood where this so-called non-contributing drainage kicks in, making those connections between individual potholes is very significant in increasing flows. So it's as I say, the idea of non-contributing drainage is kind of conceptually elegant, but when you try to apply it to an individual watershed, you have to keep in mind that in a dry year, very little of the basin contributes, and in a very wet year, almost all of the basin contributes. And again, trying to make that increasing your understanding of how much of the basin is contributing in a given year is really critical to understanding the effects of the drainage situation that you're dealing with. And it speaks to, again, looking at things on a case-by-case basis rather than drawing general conclusions.
Right, right. And in terms of specifically like the loss of wetlands, do you have any observations or comments that you'd like to make on how much the loss of wetlands is contributing to the extreme runoff events?
I think it goes back, your question is quite well taken. When you say extreme events, I'd say the loss of wetland has little effect on the extreme events, but it's those moderate events and the smaller ones that it does have an effect on. And that's the challenge. As I say, when I did some work years ago on the results of the 1997 Red River flood, and we actually had a study where we looked at to what extent wetland drainage played a part in the 1997 flood in the Red River, and the answer was very little, because all of that basin was contributing flow at that time, and you know intuitively you can sense that, but in the specific case of the Red River in 1997, there was a flood in 1830 on the Red, or 1826 on the Red River, and of course there was no modified landscape whatsoever in 1826. So again, when you get these extreme events, the effect of drainage is modest, and it's when you have the smaller events that the effect is significant.
Okay, thank you. Our next question relates to how drainage impacts groundwater. So would drainage be expected to reduce underlying aquifers?
Yeah, in general, and again, it's a general statement, but the presence of potholes does tend to recharge that superficial aquifers that we see, in the prairie landscape. And so one could assume that draining those potholes would reduce the amount of water going to the superficial aquifers. But by the same token, you can go to the Water Security Agency website and take a look at water levels in prairie aquifers, and you'll see that in wet years, the aquifers increase in level, and in dry years they go down. And so again, teasing apart the effect of the drainage on that movement of the aquifer surface, again, is something that requires attention at a sub-watershed scale. And we'd actually have to study the effect of drainage on the area contributing to the aquifer, surface area contributing to the aquifer, and make a more informed decision that way. But certainly the superficial aquifers rise and fall in concert with climate, but there is a lag. And wet years will lead to aquifers going up in level, and dry years will lead to them going down. And the effect of drainage on those aquifers would require, again, some study to tease that out of the overall question.
Thank you. All right, our next question is relating to more of a business aspect, but in the past couple of days, Wall Street has begun trading water futures as a commodity. So how should this potential issue be weighed in studying wetlands and or wetland protection, especially in southern Saskatchewan?
Yes, I'm not sure of the specific Wall Street move, but certainly in Britain, there's a lot of, in the post-Margaret Thatcher era, there was a lot of water supply systems and so on for in the UK have now been privatized, and so there are water utilities that actually provide water to communities, and there's a trading certainly in the stock of those communities, and this is similar to the situation in France. I'm not sure what the Wall Street move is, but in general terms, water is still in Canada is still a responsibility of the provinces to administer, and there's been relatively little privatization of water per se, and I don't see an immediate change in that. But of course, we all know that there have been so-called PPP developments related to municipal water infrastructure, where a private sector entity now has a responsibility for building and perhaps operating a water treatment facility or a sewage treatment facility. And in a sense, it is a quasi-privatization, but I think the provinces still jealously guard their right to administer water and I don't see a water market on Wall Street necessarily leading to any changes in Canada, but certainly the examples are out there in Britain and France of how privatized water can lead to in effect a water industry that's separate and distinct from government.
Okay, thank you. Our next two questions here are actually follow-up questions to a few things that have already been discussed. So the first one, we'll loop back to that graph about comparing Alberta and Saskatchewan. So the comment here is that the scales were not comparable between Alberta and Saskatchewan drainage. And so really the question here is that it appears that the drainage results in greater discharge in Alberta as opposed to Saskatchewan. Is there a difference in the cumulative amount of discharge greater in one province than the other?
Yeah, this is that's a nice observation. I appreciate that. The annual discharge on this figure, you'll see the questioner is absolutely right that the Alberta Plains area has a much higher discharge per unit area, because this figure on the vertical axis is translating discharge from a watershed into millimeters of water on that watershed, and you can see that the effect in Alberta, the discharge is much greater in that high plains area of Alberta than it is in Saskatchewan. And of course, the challenge in Saskatchewan is that so little of that drainage area is actually contributing. So when you take a certain quantity of water and apply it to a drainage area, much of that drainage area isn't contributing flow at all. So the millimeters on the watershed are almost trivial. And we can see a sign of that as well. If you, of course, it's a bit of an exaggeration, but the water we drink in Saskatoon is mostly mountain runoff from the mountains and foothills of Alberta, but and only 1% of the water in the South Saskatchewan River actually arises in Saskatchewan. But some 5 to 10% of it does arise in the that high plains of Alberta. So there's just the runoff per unit of area in southern Alberta tends to be higher than runoff per unit area in the flat pothole country of Saskatchewan. But that's a really good observation. I appreciate the question.
Great, thank you. And then the next question here, again, if this is a better question directed to the Prairie Water Group, that's fine. But the person is wondering how the proportional area of drainage was calculated in the graph that showed runoff depth versus proportional drainage area.
Oh, I think the questioner is talking about the same figure, if I heard it right. And no, this classification of the landscape was just to come up with this figure was several years of work by many people, and it was an enormous challenge to do this land classification. And as I mentioned, many factors were taken into account. And so these boundaries are, I think from the Prairie Water Futures project now, these boundaries are in effect fixed for the duration of the project. And that's not to say that a different set of researchers at a different time could come up with somewhat different classifications, but these are the areas that now the Prairie Water Project is using for all of its sort of hydrological process modeling for prairie systems. And these are, I'd like to say, are fixed units, and you know, there might be subtle changes that would occur, but they, you know, it's hard to visualize that these figures would change very much in the next several years.
Okay, thank you so much. Well, I'm just looking at the time here. It is 11:30, so thank you so much, Bob, for your presentation and for that informed discussions and taking all our questions. And so as we wrap up here, just of course would like to take a moment and thank our sponsors. My computer is freezing. I'm just going to take off the webcam here. All right, so our next session, we have another week-long series coming to you guys, and it's starting on January 11th. So if you're interested, you can absolutely register for those series. We will be starting off the week hearing from Murray Hilderbach on the quantifying carbon sequestration in wetlands and the impact from farmland drainage. If you'd like some more background on farmland drainage issues in Saskatchewan, you can read the Incentrix report, and that's housed on the Environmental Society website under Issues Water. And a recording of this presentation will be available in a few days on Citizens Environmental Alliance Saskatchewan YouTube channel, and you can stay up to date with updates and conference updates on their Facebook page. So I would like to just take a moment and thank our sponsors. We have the Colleen Lakes Eco Museum, Citizens Environmental Alliance, Ducks Unlimited Canada, Last Mountain Lake Stewardship Group, the Lower Capel Watershed Stewards, Nature Saskatchewan, Public Pastures Public Interest, Saskatchewan Environmental Society, Sierra Club Canada Foundation, the Saskatchewan Alliance for Water Sustainability, Saskatoon Wildlife Federation. So thank you so much for joining us today, and for those of you who have been joining us throughout the week, thank you, we appreciate it, and we hope to see you guys in January. All right, with that, I'll say take care and have a good day.